So today we're going to be multiplying polynomials. This is Mr. Trutna. I am going to be doing worksheet number 2 from Math 2. This is from Unit 9, and the problems that we're going to be doing is we're going to do numbers 1 through 4. So we go over how to set up the rectangle, the area model using rectangles, and then we're going to do numbers 5 through 29, and we're going to do the odd numbered problems in there. Okay? Alright, so in number 1, remember the idea is we're going to multiply using the area model. We're going to write the problem being modeled, and then we're going to write the solution on the line below. Okay, so the first problem here, you can see that we have two rectangles, and the idea is that we're going to find the area of each rectangle, and then we're going to add up the result in order to write down what my solution is to the problem. Zooming in a little bit so you can see it. And then we'll get started right now. So in number 1, so in order to find the area of this rectangle, I'm going to take the 4. I'm going to multiply it by the 2x. So the area of this first rectangle is 8x, 4 times 2x. Then to find the area of the second rectangle, I'm going to take the 4, which would be this side here, which would be the length. I'm going to multiply it by the positive 5, which would be the top here, which would be the width. 4 times 5 gives me a result of 20. So down here what we're writing is, we're writing the problem. So this problem is saying take 4, multiply it by 2x plus 5, and then on the other side of the equal sign we're going to write our solution. Now our solution is the combination of the areas of my rectangle, so that would be 8x plus 20. Okay, and that would be my solution. I cannot add 20 to 8x, so there we go. Moving on to number 2, I have 3 rectangles, so that means that I'm going to find the area of 3 rectangles. So the first rectangle, I'm going to take 7n to find its area, and then I'm going to multiply it by 3n to the second power. That result is 3 times 7 is 21, n to the first times n to the second is n to the third, or n cubed. To get the middle rectangle's area, I'm going to take the 7n, and I'm going to multiply it by this part here, which is 2n. 7n times 2n is 14n to the second power. Okay, why is it to the second power? Well, because that n and that n both have a 1. 1 plus 1 is 2. When we multiply, we add the exponents up. And then to get the area of the last rectangle, I'm going to take the 7n, and I'm going to multiply it by this, which is a positive 1. That result is positive 7n, and I don't have to, I just write 7n. Okay, so down here I'm going to write the problem that's being modeled. So that the problem that's being modeled is I'm taking 7n, and then I'm multiplying it by the top values of my rectangle, which is 3n squared plus 2n plus 1. And then over here I'm going to write my solution. My solution is 21n to the third plus 14n squared. I have to write plus because that 14 is positive, that 7n is positive, so I write plus 7n. That would be my solution to my problem. Okay? Number 3 here, I have an x. I have a minus 3. Since I have a minus 3, I have to think of that 3 as negative 3. Here I have an x, and then I have a minus 5, so that 5 I have to think of negative 5. So I'm going to find the area of each one of those 4 rectangles. Okay, the top left rectangle, to find its area, the terms that I'm going to multiply are x and x, x and x. So I multiply those, that result is x squared. To get the top right rectangle, I'm going to multiply x, which would be how long that is, times this, which is not 3. It has that minus sign there, so once again we have to treat that as a negative 3. That result gives me negative 3x. Okay, moving down to the bottom left rectangle, I'm going to take this 5 here, but it has this minus sign here, so that means it's a negative 5. And then I'm going to multiply it by this, which is x. That result is negative 5x. And then to get the bottom right rectangle's area, I'm going to multiply negative 5 times negative 3. That result is positive 15. Okay, so over here, what's the problem that's being modeled? The problem that's being modeled is I'm taking x minus 5, which is a binomial, and then I'm multiplying it by the top dimensions, which would be x minus 3. Okay? Over here, I'm going to write my answer. My answer is the combination of all four of those together. Okay? So if you notice, I'm going to start with x squared. So I'm going to have an x squared. But then if you notice, when I get to my next terms, I have these two terms right here, the negative 5x and the negative 3x. I can combine those together when I put them together, because they're like terms. So negative 5 minus 3 gives me a negative 8, and then I leave the x as is. And then I have a positive 15 at the end, so I write positive or plus 15. So that would be my solution to my problem that's being modeled. Number 4 here, I have 6 rectangles. My dimensions are, I have an x, I have a minus 2, so that 2 has to be negative. Going across the top, my dimensions are 3x squared, a minus x, so that would be a negative x, and a positive 4. So I'm going to have to find the area of 6 rectangles in number 4. Okay, the first top left rectangle, I'm going to have to multiply x times 3x squared to find its area. That result would be 3x cubed, or 3x to the third power. To find the area of the middle top rectangle, I'm going to take x, and then I'm going to multiply it by this side, which is negative x. So x times negative x is going to be negative x squared. Then to find the area of the top right rectangle, I'm going to take the length, which is x. I'm going to multiply it by the width, which is positive 4. X times 4 gives me a result of 4x, or an area of 4x. Okay, then I'm going to do the same thing to find the area of each one of the bottom rectangles. The bottom left rectangle, the length here is a 2, but it has that minus sign, so we have to treat it as negative 2. I'm going to multiply it by its width, which is 3x squared. Negative 2 times 3x squared gives me a result of negative 6x squared. To find the area of the middle rectangle, the length, once again, is negative 2. I'm going to multiply it by its width, which matches up with that, which is a negative x. Negative 2 times negative x is positive 2x area. And then the last rectangle, I'm going to take negative 2, and I'm going to multiply it by the width, which in this case is positive 4. That gives me a result of negative 8. Okay, so then over here I'm going to write what is the problem that's being modeled. So the problem that's being modeled is I'm taking the binomial x minus 2, and then I'm multiplying it by the top dimensions, which would be represented by 3x to the second minus x plus 4. Okay, and then over here on the right side of the equal sign, I'm going to write what my solution is. And my solution is my combination of all of these areas combined together. Okay, so I'm going to start with the highest degree exponent, because I always want to write my answer in standard form. So I have a 3x to the third. There is nothing to combine out of all of these areas with 3x to the third. So I'm going to cross that out because I've dealt with it. Then I go to the x squareds. And if you notice, these two are like terms, so I can combine them together. So a minus 6 minus a 1 is going to give me a negative 7. And then I leave the x and I leave the exponent of 2 as is. All right, then I get to my next terms, and if you notice, I have a 2x and I have a 4x, so I can combine those two together, and that's going to combine to make positive 6x. So I have to write plus 6x. I'm going to cross those out because I dealt with them. I'm going to cross those out because I dealt with them. And then at the end, I have a minus 8. I have nothing to combine with minus 8, so I leave minus 8 as is, and there is my solution. Okay, to number 4. Okay, so that's the idea of how we're going to use the rectangle model as we go about solving these. And what we're going to do is now we're going to do all the odd numbered problems. So starting at number 5, and each odd numbered problem I'm going to set it up by using the rectangle model. Okay, so I'm going to do the rectangle model for, like, let's see, how many do I have to do here? 1, 2, 3, 4, 5 of them. I'll do the rectangle model for the first 3 problems, and then the last 2, I'll show you a different method that we could use, okay, to multiply out polynomials. So number 5 right here, I'm taking 2x plus 3. I'm going to multiply it by x plus 4. So I'm going to show the rectangle model, and the rectangle model is always a good model for those of you who like a visual in order to work out your problems. Okay, so if you're a visual learner, then setting up the rectangle is the way to go. So the way you set it up is you draw a rectangle, you take what's in the first parentheses, 2x plus 3, and you write it along the top. 2x plus 3. Spread it out a little bit. Okay, then you take what the quantity in the second parentheses and you write it going down the left side of the rectangle, x plus 4. Then every time you see a plus or a minus, you're going to draw a dividing line so you can see that I'm going to divide this rectangle into 4 smaller rectangles. Then I'm going to find the area of each one of the rectangles, just like I did in numbers 1 through 4, and then I'm going to combine them to get my solution. Okay, so in number 5 here, I'm going to multiply x times 2x. That's going to give me an area of 2x squared. To get the top right rectangle, I'm going to multiply x times positive 3. So that's going to give me an area of positive 3x. Moving down and find the area of the bottom left rectangle, I'm going to take positive 4. I'm going to multiply it by the width, which would be positive 2x. That gives me a result of positive 8x. And then to find the area of the bottom right rectangle, I'm going to go positive 4 times positive 3, which gives me an area of 12. And then my solution is going to be the combination of all 4 of these areas, okay? And I'm going to combine like terms as I go. So when I write out my solution, I start with the highest exponent, which is 2x to the second. And you can see there are no other x to the seconds, so there's nothing to combine with 2x to the second. Okay, then when I get to my next exponent, which would be 1, which would be these x's right here, you can see that I have an 8x. Well, I also have a 3x, so I can combine those together. So 8x plus 3x is going to give me a positive 11x. So I have a positive 11x in my solution. And then I have a 12 at the end. That's just a constant number. There's nothing alike with just 12, so I'm just going to put a positive 12 as is. There is my solution to number 5. Okay, so interestingly enough, you notice that we started with a binomial, 2x plus 3. We multiplied it by a binomial, x plus 4. And notice our answer turned out to be a trinomial. Okay, you're going to find out as we get these, that's going to be the case a lot. A binomial times a binomial, the answer will turn out to be a trinomial. Happens rather frequently. Okay, number 7, 2m plus 7. I'm going to multiply that by the quantity m minus 4. So I'm going to do the rectangle method. It's called the area technique or the area model. Okay, so we started off by drawing a rectangle. The values in the first set of the parentheses, go ahead and write those along the top of the parentheses. So 2m plus 7, spread them out. At the plus sign, draw a line going down. The values in the second parentheses, m minus 4, write that going down the left side of the parentheses at the minus, or of the rectangle at the minus sign, draw a line. So you can see we divided this up into 4 rectangles. Okay, and now I'm going to find the area of each individual rectangle. The top left rectangle, to find the area, I'm going to take m, which would be the length. I would multiply it by 2m, which would be the width. That gives me a result of 2m squared. Okay, the top right rectangle, I'm going to go m times 7, and that's going to give me a result of 7m. All right, then I'm going to go down to the bottom left rectangle, and I'm going to take this side, which is negative 4. We see the 4 here, but you got to be careful because we have that minus sign there, so we have to treat it as a negative 4. And then I'm going to multiply it by its width, which is 2m. Negative 4 times 2m gives me a result of negative 8m. And then I'm going to multiply the negative 4 times the positive 7 to find the area of that last rectangle there. So that gives me negative 28. Then once again, my solution is going to be the combination of all 4 of these combined together and simplified. So now when I write my solution, I'm going to start with the highest degree exponent, which is 2m squared. And I have no other m squared, so there's nothing to combine. So I'm going to cross that out because I've dealt with it. Then I'm going to move down to the m's. And once again, you could see that negative 8m and that positive 7m, we can combine those together. Negative 8 plus 7 is negative 1. So I'm going to get a negative 1m, and I could just write that as negative m. And then I have this, I'm going to cross those out because I've dealt with them. And then I have this negative 28, nothing to combine with it. So that is my solution to number 7. Okay, now we move on to number 11. Now in number 11, you notice that I'm actually multiplying 3 things together, 3 expressions together. I have a 4, I'm multiplying it by the a plus 2. So I'm going to do that first, and I'm just going to do the simple distributive property. So I'm going to go 4 times a, that's going to give me 4a, and then I'm going to go 4 times 2, and that's going to give me a positive 8. So multiplying out the 4, I get 4a plus 8. Now I have to multiply that result times 3a minus 2. Okay, so I'm going to set up the rectangle again. In order to multiply, I'm going to use the area model using the rectangle to multiply 4a plus 8, and I'm going to multiply it by 3a minus 2. Okay, so along the top, I typically write the first, whatever's in the first parentheses, 4a plus 8. You could write 4a plus 8 along the left side, and then along the left side, I'm going to write the 3a, the minus symbol, and the 2. At the plus symbol, I draw a vertical line. At the minus symbol, I draw a horizontal line. Okay, so you could switch these around if you wanted to and write the 4a plus 8 down the left and the 3a minus 2 down the right. Okay, it doesn't matter which order we do it. It's kind of like saying, doesn't matter which way you multiply 2 times 3. 2 times 3, 3 times 2, they're the same thing. Okay, so I'm not going to write out each one. What I multiply, I'm just going to talk about it in this one. So the top left rectangle, I'm going to take the 3a, I'm going to multiply it by the 4a. That's going to give me a result of 12a squared. The top right rectangle, I'm going to go 3a times positive 8, so that's going to give me a positive 24a. The bottom left rectangle, I'm going to take 4a, and I'm going to multiply it by this 2, but it has to be a negative 2. So that's going to give me negative 8a. And the bottom right rectangle, negative 2 times positive 8, that's going to give me a result of negative 16. And so my solution is going to be the combination of all 4 of my areas of each individual rectangle. Writing out the solution, I start with my highest exponent, which is 12a to the second power. And you can see there's nothing like with that, so I'm going to cross that out because I've dealt with it. Okay, then I move to my a's. And you can see, once again, these 2 parts are, they're like terms, so I can combine them. It's very typical, as you can see, that when I have 4, when I do the rectangle model, the area model, these 2 rectangles turn out to be like terms. That's a very common part that happens. Not all the time, but I'm going to say probably 9 out of 10 problems that happens. Negative 8a and a positive 24a, I combine those together, that gives me a positive 16a. I'm going to cross those out because I've dealt with it, and then you can see I have the constant negative 16 and nothing to combine with it, so there is my solution to number 11. Okay, now I'm going to do number 13 and I'm going to do number 15. And what I'm going to do now is I'm going to do the rectangle model, but I'm not going to draw the rectangles. So I'm going to show you how to do these problems without drawing the rectangles. Okay, and for some of us who don't like or are not visual learners, that might not be a bad way to go about doing the problem. Okay, and I'll pick that up on the next video.